All right, I have ship A and B leaving from the same dock. So ship A is sailing east at 35 kilometers per hour. So even though you want to put maybe you want to put the ship here, you want to label this side length as A. And then ship B is moving north at 25 kilometers per hour. So again, you want to label that side length as B. So they're giving us two rates this time. dA over dt is 35, it's getting larger, and dB over dt is 25, that's getting larger. And what are they asking us to find? The rate, the distance between them is changing, so find dC over dt. And the when information is very different this time. The when is changing at 4 p.m., so I'm going to use the fact that it's talking about when t equal 4, and I'm going to save that and figure out what that means later. So I've got the given rates, the find rates, the when information, so let's get an equation going. So I better put my c in my picture. And so my equation is c squared equal a squared plus b squared. So 2c dc dt, 2a dA dt, plus 2b dB dt. Okay, so I can cancel all the 2's. So now I can use my when information to figure some things out. So when t equals 4, I have to go back and look and say, oh yes, it started at noon. 4, that's how I found out that 4 o'clock meant t equal 4. So I'm going to draw my picture again. So I'm going to figure out what this side length A is going to be. So side length A is 35 miles per hour, kilometers per hour, times 4 hours is 140 miles. And side length B is 25 miles per hour times 4 hours, so that's 100. So then, to go find the C, I use Pythagorean theorem, so that's the square root of 140 squared plus 100 squared. So let's go plug all that information in. So I have c dc dt equal a, 140, times dA dt, which is 35, plus b, which is 100, times dB dt, which is 25. And so to finish it off, I would divide through by this 140 squared plus 100 squared. So 140 times 35 plus 100 times 25.